Hello, my friends. Today's video is about Empress Ashina. She was a historical Turkic empress from Mongolia. As you can see, I'm starting this video different from the way I usually do. I'm starting it by um, showing to you my results with illustrative DNA. I know it's really cool, but as you can see, I'm scoring 94% Pannonian Slav plus 6% Empress Ashina. So let's click on her and let's see what she's described as. So she's from China. Okay, I was wrong. I thought she was from Mongolia, but it turns out she's from China. Her mitochondrial lineage is F1D. And it says here that she was an empress of the Xianbei-led Chinese Northern Zhou dynasty. She was the daughter of Mukan Hagan, and her husband was Emperor Wu. The first genetic analysis of Empress Ashina in 2023 by, I can't pronounce that, found nearly exclusively ancient Northeast Asian ancestry next to minor West Eurasian components. So what we can expect from this is that she's very East Eurasian, and she doesn't have much West Eurasian admixture. The ancient Turk royal family of the Turk Khaganate was found to share genetic affinities to post-Iron Age Tungusic and Mongolic pastoralists while having heterozygous relationships heterogeneous towards various Turkic speaking groups, suggesting genetic heterogeneity and multiple sources of origin for the population of the Turk Khaganate. So, although most of the Turkic people in this Khaganate were a mixture of Eastern and Western Eurasian, she is very Eastern Eurasian, as you can see with the populations closest to her. She's closest to various populations of Siberia, and this is what she scores with Eurogenes 36, and we're gonna talk about her result a little bit more. So here she is scoring 32% East Asian, 31% Siberian, 29% East Central Asian, which is also kind of like a very Eastern component. But it's interesting that she's scoring that, and 3.97% Volga Ural, which I guess is the West Eurasian component that she scores. So she does have a little bit of Volga Ural or like Erzya or Tatar or Mari like admixture. So she has some European admixture. The very far east of Europe, but it is still Europe. It is still, in my opinion, Volga Ural is still European admixture. And then she scores 2.3% South Chinese. So she's very Siberian in her result. Her closest populations are Kalmyks, Hezhen, followed by Kyrgyz, followed by Altaians, followed by Buryats, and it's basically various Siberian groups. So she's very pure. She doesn't really have any admixture from outside Siberia, which is definitely very interesting. Now we're going to be looking at her results with my trait predictor. First, I have to say it's not a very high quality file, so I'm not going to show you the phenotype oracle. It's completely deranged. I will show you the Nashakot calculator results, but as I said, it's not a very high quality file. So a lot of the relevant stuff is not found in the file. Like most of the relevant SNPs for coloring, unfortunately, are not in the file. Let's look at the ethnic calculator results. Once again, you can see that the problem with the file is that she's got 130 SNPs. So this prediction was done on the basis of 130 SNPs. That's very low. For a more or less accurate prediction, you want to have more than 400. But 130 SNPs, you're not going to get a very good prediction. And she's closest to Onge, followed by Anzic Amerindian, followed by Polynesian, Sri Lankan. After that come Kazakh, then Uyghur, and only after that come Jamon and Mongols from Mongolia. So she's very different results from what you see with GED match. Of course, GED match, there's a lot. The calculators for ethnicity on GED match are a lot better than what I made. My shtick, like trait predictor shtick, is that it's good at predicting traits. It's a trait predictor. It's not necessarily an ethnic calculator. But with the model, the closest model for her is a mixture of Chinese plus Большой Оленей Остров. The second closest two-way model is Korean plus Sarazmi Neolithic from Tajikistan. The third closest model is Bactrian plus Korean. In case you don't know of course we all know what Chinese and Korean is, but Большой Оленей Остров is basically like early Finno-Ugric people from Finland. Sarazm in Neolithic Tajikistan is basically inhabitants of Central Asia before the Indo-Europeans got there. Bactrians are more like basically Iron Age Central Asians, Turanian people. Punjabi Jat, we all know what that is. So Punjabi Jat plus Chinese is the fourth closest mixture. So with this, with my ethnic calculator, it looks like there is more West Eurasian admixture. than with Eurogene's K36, right? Eurogene's K36, there is no West Eurasian admixture at all. With my ethnic calculator, she does score a lot of West Eurasian stuff. But then again, we have to keep in mind that this was done on the basis of 130 SNPs, definitely very limited SNP count. Let's look at Nashakot calculator results, and they are kind of ridiculous. I mean, she's scoring all over the place for eye color. The largest percentage for eye color that she scores is brown eyes still, but despite that, it's just a very ridiculous result because most of the relevant variations are not found in the file. So because of that, she's scoring kind of all over the place. For hair color, it is a little bit more definite. So for hair color, she's scoring 63% likelihood of black hair. Hair color distribution likelihood is definitely more definite, but still, it is not what you would want to see. And for skin color distribution, once again, it is really all over the place, but the largest category she scores is olive or Mediterranean skin. And for hair texture distribution, once again, it is really all over the place, but the largest category she scores is actually kinky hair. Very, very surprising. So obviously, um, if you see results like this with the Nashakot calculator results, the phenotype oracle is going to be very messed up as well. And I'm going to show you why the results are this way, because look at that. She does not have any of the genotypes relevant for blue eye haplotypes. None of them. She does not have any relevant genotypes for this region whatsoever. She's got this, but this doesn't really say much. She's got this, but this also doesn't really say much. So you can't really predict what her eye color is based on the genetic data. Look at how much data she's missing. She doesn't have. This is a really important variation for the pigmentation of eyes, hair, and skin. She doesn't have any data for this. Once again, these three are very important variations for the same traits. She doesn't have any data for that. So how can you really even determine what she looks like when you don't have any genetic data in the file, right? Actually, let's see what she would score with YSEC. Hold on. Just let's see what she'd score with YSEC. Let's do it. It's gonna be blonde and blue-eyed, isn't it? Oh, come on, dude. Yep. That's what she's scoring. Yeah, that's what she's scoring with YSEC. Come on. So trait predictor results. Nashakot results here might be a little bit deranged, but they're still sort of in the right place. There's still brown eyes. There's still black hair. There's still olive or Mediterranean skin, even though it's a really low quality file. But YSEC is just giving out this 95% likelihood of blue eyes, 92% likelihood of light hair. That's crazy, right? So that's completely out of the left field. All right. Let's go ahead and see what she scores for the biomarkers. I'm just showing you that even with low quality files, my trait predictor is sort of adequate. Let's look at the biomarkers panel. It looks like she's got slightly above average levels for vitamin D. All right, it looks like she's got a pretty much average level of LDL cholesterol, which is really good. Slightly below her level for HDL cholesterol, which is kind of not so good, but it's okay. It's still really close to the typical range. She's got slightly above average level for glucose. All right. She's got typical level of hemoglobin, really good. She's got slightly above average blood pressure, which is kind of not so good. It's more in an elevated region for blood pressure. For expected level of iron in the blood, she's got a slightly above average level for iron in the blood as well. Excuse me. So that's kind of typical. For sex hormone binding globulin, she's got slightly below average level for that, but still very well within the healthy range. And for red blood cell count, she's got slightly above average count of red blood cells as well. So that's really good as well. So overall, the biomarkers look pretty good. I don't see risk for hemochromatosis from the biomarkers at all. Let's look at the polygenic risk scores and see what she scores for that. So it looks like she's got 1.47 times the average odds of leukemia, definitely much increased odds of leukemia. She's got typical or average odds for vitiligo, which is kind of, I think nothing is found here. Nothing was found in the file, so that's why she's scoring this. She's got slightly above average odds for myopia. All right, she's got slightly below average odds for primary biliary cirrhosis. Nothing relevant was found in the file for stroke, which is really surprising because from my memory, there is like 8 different variations that go into the risk score for stroke. So she's scoring. She doesn't have any genotypes for any of them, which is really really crazy. She's got above average odds for male pattern hair loss. Okay, she's got slightly below average odds for atrial fibrillation. Nothing relevant was found for deep vein thrombosis. Once again, that's really surprising because there's like, I swear there's like 7 different variations that go into deep vein thrombosis risk score, and she doesn't have any of them in the file. I mean, it's like just a really. I did not want to make a video on her precisely for this reason, because I tend to not make videos about low quality samples. But somebody on YouTube asked me, "Can you make a video about her?" So I decided, I'm gonna do it. I'm gonna make a video covering her. So she's got pretty much average odds for bipolar type 1. She's got pretty much average odds for schizophrenia. Looks like she's got above average odds for type 2 diabetes. It looks like she's got a below average odds for Alzheimer's. Nothing relevant was found for multiple sclerosis once again. Okay. Zero risk finance for breast cancer out of 2. Out of 2, bro. Out of 2. I mean, do you realize how awful that is? Out of 2. Like normally, if you have even if you have like a my heritage file, it's gonna be out of 24 or out of 26, not out of 2. She's got 4 risk finance for testicular cancer out of 8. Come on, dude. 0 risk finance for celiac disease out of 0. Nothing was found for celiac disease at all. All right. 0 risk finance for GSS out of 0. Once again, nothing was found for that. 4 risk finance for Crohn's out of 6. 4 risk finance is not that much for Crohn's, so there's not that big of a problem here. Nothing relevant was found for Riefenstein's, and 4 risk finance for Parkinson's out of 12. Okay. Okay. Let's see what she scores for the monogenic traits, and we're gonna move on from that. So she's got GG in COMT met variation, meaning warrior genotype. She's a warrior in COMT. So which means higher activity of the COMT enzyme and quicker breakdown of dopamine. Therefore, less dopamine levels and advantages in stress resilience, but disadvantages in attention tasks. It looks like she's got a predisposition to pretty much intermediate number of dopamine D2 receptors. I don't really want to talk about all of these genotypes. It's unpleasant. For OXTR, it looks like she has a predisposition to higher empathy, which is surprising considering her ethnicity. But it is based on one genotype in OXTR. So once again, on the basis of this one genotype, she's got a predisposition to higher empathy. For lactose persistence, it looks like she does not carry the European lactose persistence mutation. Hemochromatosis, nothing relevant was found. Alzheimer's, it looks like she does not have risk variance for Alzheimer's in APOE. So, it looks really awful, this report, because so much of this data is just missing. So much of the data is not here. This file is actually not that terrible if you look at the size. In terms of the size, it's a pretty decent file. But somehow all of the variations that are in the file are completely irrelevant to my trait predictor. For cardiovascular disease panel, it looks like she's got some genotypes that predispose to higher odds of cardiovascular disease, such as this one, for example, 2 times increased higher early heart attack risk. For facial morphology panel, she doesn't even have any genotypes in EDAR. The only genotype we have here is that she's got CC here, which corresponds to larger nose size. Definitely very interesting. Vitiligo panel, literally nothing is here. For drug response, she's an extensive CYP2D6 metabolizer. All right. I don't really want to talk about this, to be honest. She's got this genotype, which leads to a 2.5 times increased risk for lymphoblastic leukemia. I think this might be the only genotype for leukemia that she even has in her file. For rare diseases and traits panel, let's see, does she have any rare diseases? Nope, not really. Celiac disease panel, nothing relevant was found. For male pattern hair loss, it looks like 4 genotypes were found, and they all increase the risk of male pattern hair loss, except for this one, which actually reduces the risk of baldness. Okay. For HIV and AIDS panel, nothing was found. For muscular dystrophy myopathies, no risk variance for that, so that's really good to see. For color blindness panel, 0 risk variance for that. Once again, really good to see. For FTO gene panel, she's got a genotype that increases BMI. She's got a genotype that lowers the risk of obesity and insulin sensitivity. So kind of, I guess, counteracting genotypes. She doesn't have any genotypes in the actual FTO gene, which is unfortunate. And for syncopes, based on 2 SNPs, she's got a slightly below average odds for syncope. For biotraits panel, let's see that. She's got dry earwax, no body odor, likely Asian ancestry. That's very interesting, right? So this is one of those variations where there's a big difference between Asians and Europeans. Europeans, like me, for example, tend to have wet earwax and have body odor, like smellier armpits or whatever, whereas East Asians tend to have this opposite genotype, which I'm not sure the chemical reasoning behind it, why they have dry earwax and no body odor, but she's got this East Asian phenotypical trait, which is definitely very interesting. She's got CC here, which is common in complete genomics and does not does not result in extraordinary testing ability. So she does not have extraordinary testing ability. Okay, she's got 2 times higher early heart attack risk based on her genotype here. Decreased odds of vitamin D insufficiency, so that's good. And she's got a genotype that increases blood pressure and increases red blood cell count. Let's move on to the blood group panel. So with the blood group panel, she's actually predicted to have type B or AB blood, but I don't trust this very much. You know why? Because I only see 2 genotypes here showing up for the calculation. Just for context, like if you look at a good file, you're gonna see like 15 or 14 genotypes. In this case, you see 2. So on the basis of these 2 genotypes, she most likely has type B or AB blood, but um, I wouldn't take it too seriously, to be honest, this kind of a prediction. Anyway, tell me what you think about this file. Do you think I wasted your time with this video, showing you a very low quality file, or did you enjoy it and did you find it interesting? Thanks for watching, and of course, I would leave I am gonna leave the link. Yeah, I'm gonna leave the link to download the file in the description of the video. I was thinking I wouldn't because I already had it on my Google Drive, but why not? I'm gonna leave the link as well. Thanks for watching. Goodbye.